In this video, I will quickly introduce and discuss Lewis' definition of acid and bases. So the Lewis definition of acid and bases is much broader than the Bronsted and Lowe definitions of acid and bases. And in the Lewis definition, acidity and basicity are described in terms of electron. So the emphasis is on electron rather than the proton that we have seen in the Bronsted-Lowe definition. And in comparison between these two definitions of acid and bases, this is as follows. In the Bronsted-Lowe definition of acid and bases, an acid is a proton donor and a base is a proton acceptor. And now in the Lewis definition, an acid is an electron acceptor and a base is an electron donor. So again, the emphasis here is on the electron in the Lewis definition, versus an acid, the emphasis is on the proton. Now, an acid would be an acid in either definition, and same thing with the base. But the emphasis is on the different thing, because essentially, an electron acceptor is basically a proton donor. Because as something accepts electron, it then gives up its protons. So therefore, an acid will be an acid in either of this definition, and same thing with the base as well. But why do we need to use the Lewis definition? Then the Lewis definition is basically an expanded definition of acid and base that allow all the molecule to also be considered as acid and bases as well. So it is an expanded definition of acid and bases because it includes reagents that otherwise would not be classified as acid and bases. For an example, in this reaction right here, where water is donating an electron to the boron from this boron trifluoride, if we were to analyze this reaction right here and using the Bronsted-Lowe definition, we would not consider this to be an acid or base reaction because no proton is being transferred in the course of this reaction. So therefore, we can't consider this to be an acid and base reaction according to the Bronsted-Lowe definition. But now, if we were to now use the Lewis definition, in this case right here, this oxygen or this substance, water, is donating an electron to the boron in this case. And so because this is donating the electron, this is what a base would be. And this in this case right here, because the boron is accepting the electron, so therefore that an electron acceptor or an acid. So these two molecules right here will be classified as acid and base, and this is an acid and base reaction by the Lewis definition. But it would not be an acid and base reaction if we were to use the Bronsted-Lowe definition. So again, the Lewis definition is an expanded definition to include more reaction in there that otherwise would not be considered as acid and base reaction by the Bronsted-Lowe definition. Let's try a few examples and identify the Lewis acid and the Lewis base in this following reaction. So here in this case, we are given this reaction and we need to identify which one is the Lewis acid and which one is the Lewis base. So here in this case right here, by looking at the product, we will then see electron is being donated from this oxygen into this aluminum to form this bond. And because this is an electron donor, so an electron donor will then make this a Lewis base. And this aluminum right here is then the electron's acceptor because it gained an electron in this course. And this will then make this a Lewis acid. So that's how we can determine Lewis acid and Lewis bases in the course in this acid and base reaction.